If you like the ALU video, you'll probably like this. This is a 4-bit CPU, Central Processing Unit, built on 3 different breadboards here. There are 7 TTL chips on the first breadboard there that form an arithmetic and logic unit, ALU. The next breadboard here we have 2 chips forming some decode logic, and a third chip which figures out whether or not the result from the ALU was 0 or not. One accumulator to store the result from the ALU. We have the next chip over here is the flags register to store the result of the flags from each ALU operation. We have a multiplexer to select which flag is going to control a conditional jump. Another multiplexer over here which selects whether the input from or input to the opcode is a data from memory or data from the immediate mode program data. The last 4 chips here could be implemented in less if I had them. We have a 175 flip-flop, a 257 multiplexer, 08 AND gate, and an 86 exclusive OR gate. Together those guys form a presettable counter with a asynchronous reset, which you could implement in one chip if you happen to have a 74LS161 on hand, and if you had that plus an inverter, you could also drive the LEDs over here. There are 13 LEDs on the board. Number 1 is just the system clock. 2, 3, 4, 5. Over here in the next group of 4, those are the accumulator status. The next 2 are your carry flag and 0 flag from left to right respectively, and the last 4 are the program counter. The CPU as designed is designed to be interfaced with RAM up to 8 bytes of RAM and up to 16 bytes of program storage for ROM, so it's not strictly a von Neumann architecture machine, but it is fairly functional. A couple of control inputs we have, you can see here, single step, control, and reset. Control is an option in addition to the carry and 0 flags. Based on the status of that switch, you can also make a decision in your program with a conditional branch. Single step is should be pretty explanatory for those who have a lot of CS background. Should be a push button there, but I just don't happen to have an SBDT push button on hand. One cycle of the single step switch would execute 1 instruction in the CPU, and of course the reset switch here, if we push that, is going to reset all of our registers to 0. And our flags register, you'll note there is the carry flag is set to 0. The 0 flag is set to 1, but that makes sense since our accumulator actually is set to 0. So that's our sensible reset there. We have a couple of instructions that we can implement with this CPU at the present time. 010 is an exclusive OR operation, and we just input our, because we have no ROM attached, input our opcode with these 8 dip switches here. 010 is exclusive OR. 1 takes the operand from the opcode, and 1001 should exclusive OR our accumulator, which is all zeros with 1001. And after we execute that instruction, we get 1001 in our accumulator. We also have an AND instruction, so we should be able to clear any of these bits if we want to. AND instruction is 000, and let's just clear our most significant bit here. So we're going to AND our 1001 with 0001, which should result in just the least significant bit of our accumulator being set, as you can see there. We also have an OR instruction, so we could OR our result, and the opcode for OR is 001, and we're going to OR our accumulator now with 0011, so we should set the second bit in our accumulator. As you can see there, we set our second bit. And the fourth and final ALU instruction is an addition instruction. We have three in our accumulator. And let's add, I don't know, 9 to our accumulator. Opcode for add is 011 and a 1 for immediate data. And we're going to add 1001 to that, which would be 9 plus 3 should give us 12, and we get 12 as our output in the accumulator here. You'll notice each time that we step through our instructions, we add 1 to our program counter, just like so. We also have instructions to jump. We can always jump if we do a 110 opcode. So that will always jump to the address that we give it in the least significant 4 bits of the opcode. And we'll jump to, I don't know, let's say instruction 5. We now have 1001 in our program counter, and we'll execute this. We should go to instruction 50101 in our instruction counter, and we can also do conditional jumps. Obviously those are pretty self-explanatory, but those are basically the 5 instructions that this CPU has, and bitwise AND, bitwise OR, bitwise XOR, an add instruction, and a conditional branch instruction. And like I say, this is designed to have an actual ROM attached for program storage and a RAM attached for data storage. We're just not there yet with the breadboard. So hope you enjoyed it, and I look forward to hearing some comments. Thanks.